This is problem 2, part C, the last part of this problem. And what's the difference now? So this cheese of mass m is sitting on this rotating platform, let's assume distance b from the center. There is coefficient of friction between this piece of cheese and the platform. It is mu. And now, at time moment 0, this platform was at rest. And then it was giving an angular acceleration, alpha naught. And the platform was rotating with this n constant. This is constant angular acceleration, alpha naught, about the axle. What we need to find? We need to find the equation that could be solved for time t, this special time t, right before this piece of cheese will start slipping. So what is time t when it slips? So it makes sense to us. So it starts from rest, then it is accelerating and accelerating and accelerating, and at some point this piece of cheese will be ready to slip. It will be ready to run away. What is this time when it happens? How to find it? Do we understand that force of friction in this case, similar to what happened in the previous case, has its maximum value? It's a critical situation. It's ready to slip. Magnitude of force of friction is equal to mu, coefficient of friction, times normal force. Maximum of force of friction, static friction, at mu n, at its maximum. N is mg, so it is equal to mu mg. We know the magnitude of force of friction. How to find time? Well, where will be this time? Let's look at our second law. We know something about the forces. There is magnitude of force of friction that is given. Here is omega, here is alpha. Alpha is not 0 anymore. We need to correct this part. It's not 0 anymore. I raise this 0. There is non-zero alpha here, okay? If I know alpha, can I find omega? Yes. Remember the equation? What's the definition of alpha? Alpha is d omega dt, which means that omega is integral alpha dt. Alpha in this case is constant. It is just alpha naught times time plus constant c. But this constant is 0 because at time moment 0, the platform was at rest. They gave it to us, this information. So what is omega? It is not constant anymore. It is function of time, alpha naught times t. So we know omega. We know r. Why don't we write radial component of force of friction? Fr is equal to m. Then this guy is 0, and then it is minus. R is b. And then omega squared is alpha naught t squared. This is omega squared. This is radial component of force of friction. What about tangential component of force of friction? Before that, it was always 0. Is it 0 now? No, because we have non-zero alpha. So I have non-zero tangential component, F theta, which is equal to m, and then r, which is b, and alpha, which is given quantity alpha naught. Instead of having force of friction just in radial direction as we had before, now when this platform is accelerating, force of friction has both components. And we need to find the magnitude of force of friction. And if we find the magnitude of force of friction, time is here, and we put it equal to mu mg, we will have the equation that we can solve for time, that specific time when this piece of cheese is ready to slip. So both components of force of friction are known. What is the magnitude of force of friction? The magnitude of force of friction is square root of Fr squared plus F theta squared. And at the same time, it has to be equal to mu mg. And let me plug in my Fr and F theta component in this formula. I will write it in red at the top, right here. So F square root Fr squared will give me m b alpha naught t, where t is t capital. And I will put it squared. So it is alpha naught squared, t squared. And this is Fr squared plus F theta squared, which is m b alpha naught, all given quantities, squared, square root. And this has to be equal to mu mg. Remember what they asked us? They asked us to find an equation that could be solved to find time t when this piece of cheese is ready to sleep. Did we do that? Have we achieved that? What do we have? We have one equation and one unknown, t capital, time when it is ready to sleep. Every other quantity is given. So we solved the problem. We found the equation that could be solved to find t capital. One equation, one unknown variable, problem solved. What's the difference? Why I decided to introduce this part C? Because now we have non-zero angular acceleration. The platform is rotating, it is accelerating. And instead of having force of friction just in radial direction towards the center, as we had it in parts A and B, now we have both components of force of friction. It is towards the center, and it is also along I theta. So we found both components, then magnitude, and put it equal to mu mg.